Assalamualaikum. Today my group members and I will present about integration for our group assignment. We are from Faculty Computer Science and Mathematics course Diploma Statistics CS1111. We are from group A4CS1111A. This presentation is for our group assessment 3 code subject MAT183. Let me introduce the group members first. First, Muhammad Syafitri bin Roslan. Second, Muhammad Safiuddin bin Ismail Johari. One, Muhammad Adham bin Zainal. And lastly, myself, Muhammad Adib bin Khairul Adnan.
What is integration? Integration is the process of finding integral. In mathematics, an integral assigns number to function in a way that describes displacement, area, volume, and other concepts that arise by combining insufficient data. The reason we use integration is basically to find the area of two-dimensional region and computing volume of three-dimensional object. Therefore, finding the integral of a function with respect to x means finding the area with respect to the x-axis and the curve. The, applica- the application of integration in daily life. In physics, integration is very much needed. For example, to calculate the center of mass, the center of gravity, and the mass of moment of inertia of a sport utility vehicle, and also to calculate the velocity and the trajectory of an object, and predict the position of planet and understand electromagnetism. And that's how we use integration in our daily life.
So this is the problem statement. Okay, so an airplane flying at 450 km per hour at a constant altitude of 5 km is approaching a camera mounted on the ground. Let theta be the angle of elevation above the ground at which the camera is pointed. When theta equal to pi over 3, how fast does the camera have to rotate in order to keep the plane in view? Okay, the first thing if we highlight the key, which is 450 km per hour, constant altitude of 5 km, theta be the angle, theta equal to pi over 3, and the last one is camera have to rotate. Okay, so constant altitude of 5 km, so that means 5 km from the ground. So 5 km is opposite of the theta of the theta, which is theta is the camera. Okay, so this is x and theta equal to pi over 3. Okay, this is the problem solution. Okay, the first we differentiate tangent theta equal to 5 over x, and tangent theta we will get secant square theta d theta over dt equal to negative 5x power of negative 2 dx over dt. So secant square theta we can change into 1 over cos square theta d theta over dt equal to negative 5 over x square dx over dt. So 1 over, so cos theta equal to, so we can write cos theta equal to cos pi over 3 theta. Theta, we replace the value of theta with pi over 3. So the answer is 1 over 2. And the second one is tangent theta. Okay, we replace the value of theta with pi over 3. Okay, tangent pi over 3, we will get square root 3. So we need to substitute the value of x, cos theta, and dx over dt into the equation. So 1 over cos square theta we substitute, 1/1/2 square dt over d theta equal to -5 power of negative 5 divided by 5 over square root 3 square multiplied by -450. So the answer is 67.5. So that's mean the answer is the camera need to rotate 67.5 radius per hour. So that is the answer. Thank you.
So, for the conclusion is differentiation in integration, considered by all scientists throughout the ages as one of the best sciences that guide the minds of for all time. So, actually, the fields of calculus, like integration, are very wide. It enters into many fields and it not specific, it not limit to the specific people in on the specific jobs. But to almost all human beings, we are using it right now, actually. So here are some examples of its benefits. First, we can actually in the swimming pool, if you use a swimming pool right now and you want to calculate the amount of water in it, so what should we do? So to solve this problem, integration is being used in these cases. The answer is to determine the shape of the swimming pool and find its size. Therefore, we find the size of the water that will fill it. If it is a Rubik or parallel rectangle, or finding its size is not difficult in any way because there's geometry shapes are regular. So many students can find their size. But what if the shape of the swimming pool is not the regular geometry that we can find nowadays? So for example, it begin with the slight gradients and the slope descends steeply. So then the sides of pool become curved. You have no curve. So or the same or semi-elliptical. Then what should we do? So for this to solve this problem, of course, then it tends to rise slightly. For this, do you know that for calculate all of this need some calculation from integration. So do you think is it easy to find the size of water to fill the pool? Of course, yes. This is science of calculus right now. So that's all for me, and that's all for us. See ya. Thank you.